Okay, as next I will show you how you can define the tool TCP. For this I already installed here a metallic part on the desk in front of me, and I place this pin somewhere on this metallic part. You can use any kind of tips or pins with which you can define the tool TCP. In my particular case, this is the tool, so this is Robert's pen inside in 3D printed cover fixed on the robot. So what we have to do is we just select the tool, the right one. We check if it's the active one, this is the active, and then we just hit define TCP. Alternatively, you could use the define TCP from the menu as well. I use it from here. So define TCP. Please check this out. If the correct tool is selected, it's very important that the calibrate method is using the joints, and the robot should be the right one. In our case, we have only one tool, one frame, one robot, so this is easygoing. I recommend you to use a higher number of positions, let me say 10 or even more. The more points you are using for this initial tool TCP definition, the more accurate the result what you can reach. I will reduce this time only to 4. This is the minimum number. If you see, if you reduce it to 3, then you are not. This is too low. So I recommend you to use at least 4. And before we start with, I would like to show you that I'm already connected my robot with the TCP IP cable. So I can hit in RoboDK connect robot, and this opens up this surface. For this, to check this out, how it looks like, I just come into the settings. The remote control is enabled, and I check out the network. So the IP address is on the teach panel, which I typed in. Normally, I just open this up. Normally, you have with the options, you can check out if the correct driver is installed. If I hit connect, then we should see what happens. For sure, for this purpose, I have to first activate the remote mode on the robot, and it seems to be ready. Oh, sorry. So if I change the position of the robot, for example, to this one, then if we hit the get position button, then you see that on the screen the robot position was applied exactly one by one as it looks like in front of me. So this will make our job far more easier, because right now I will just come in the free ride mode to this tip, and the rest I will do in the jog mode, reducing the speed. Okay, it seems to be fine. So first I get the new position of the robot. For this, unfortunately, I have to come back to the remote mode. So you can see that this is the new position. And I just simply hit get P1. So this position, exactly this position of the robot, will be transferred to the RoboDK. If you are not so lucky that you can connect with your your robot with the RoboDK directly, then here on the teach panel you can see the values, and exactly these kind of values you can find on my screen as well. So what I will do right now, I will teach a new position. Okay. And this is very important that you can really, I just show you that you can really hit the tip as precise as possible. Okay. So just wait a second. I just try to do this. So a little bit lower. And here you can see that this seems to be quite precise. So we will apply, and I do this all the time with the same method, just for your reference. Okay, so we will apply it from here. First, I have to come back to the remote mode again. I just get the new position. You can see on my screen that it was changed. Okay, this is very good. And then I just get the new position. So we'll just get a third position for this. Let's do this in a way that you can really see on the big picture as well. So I'm coming back to the remote local mode, to the jog. Okay, we are just reading out the new position and we just enter it. Okay, very good. And the last one, for example, let's try it so, and the rest I'm doing with the remote mode again, jog mode, sorry. Okay, seems to be fine. We just switch back to the remote mode, get positions, bam. So here you can see what is the TCP error, what we could measure. If I hit update, bam, and the TCP here on the robot was applied exactly to the same position. As this is a quite regular one, I mean, this is a concentric device. If you check this out, you can see that 0.2 x, the y coordinate is 1.4, and the z is 105. So this seems to be quite accurate. I mean, for sure we have a small inaccuracy, so most probably the y should not be 1.4, but this should be really 0 as well, just for a simple purpose. This should be concentric. But I will let it so for this demonstration, just for you. If you can really follow up where should be the point of the tool, then this is easy going, then you can define it even manually. I mean, this value with a 105.8 seems to be quite valid. The 0.2, this is excellent. So in overall, I think this calibration this tool calibration was a good one. I just hit record, hit the save button again, and I just come back to a normal neutral position with this robot again. Okay, and we will just move to the next step.